Assalamu alaikum girls. How are you first year? Welcome to physics class. Today we are going to do a very important derivation from our second chapter, scalars and vectors. Open your notebooks and give the heading addition of vectors by rectangular components. That is the components which are mutually perpendicular. They are at 90 degrees with respect to each other. This is a very important derivation and it comes as a long question in board exams. So you have to prepare it very well. Now then, draw neat figures. I will go very slow so that you can note the important points. So start drawing the first figure, the two axes with the origin O. One is the x-axis and the other is the y-axis. They are perpendicular to each other. Now let us consider one vector A. This vector A, you can take it of any length and in any direction. So what is it? This is vector A. It is making an angle theta 1 with respect to plus x-axis. Now let us draw another vector which is vector B. This vector B, you can draw it of any length in any direction. So what is it? This is vector B and it is at an angle theta 2 with respect to plus x-axis. So we will now add these two vectors by head to tail rule. We will resolve them into their rectangular components and then we will find the resultant vector. So let us draw the other figure. बेटा ये फिगर ज़रा बड़ा बनाइएगा क्योंकि इसमें हमने rectangular components भी show करने हैं. So again the two axes with the origin O, one is x-axis, the other one is y-axis. So now let us redraw vector A. This vector A, again of same length as that in the first figure. The two components, one component is along x-axis and the other component is along y-axis. What is this? This is vector A and it has an x component, vector AX, and it has a y component, vector AY. It is making an angle theta 1 with respect to x-axis. Theta 1 must be same as that in the first figure. Now we need to redraw vector B. The tail of vector B must join with the head of vector A. For this we are drawing a line which is parallel to x-axis. This line will serve as x-axis. Now let us draw the other vector, vector B, of same length and the two components bx and by. The length of vector B must be same as the length in the previous figure. This is vector B, this is x component, vector bx, and this is y component, vector by. Vector B is making an angle theta 2. The value of theta 2 must be same as the value of theta 2 in the first figure. Now let us bring this bx on x-axis so that both vector ax and vector bx lie on the same line. So I am going to draw a vector in the same direction of same length as that of bx. It means this vector is also vector bx. क्या किया है मैंने? I have brought vector ax and vector bx in the same direction on the same line. Similarly, I will draw a vector of same magnitude and same direction as that of vector ay. So this vector is also vector AY. Again, I have brought AY and BY on the same line. So what is the resultant of these two vectors, vector A and vector B? Let us draw the resultant vector R, which is directed from the tail of first vector A to the head of second vector B. This vector R is called the resultant vector of A and B. What is this? This is vector R. Just like vector A and vector B have x and y components, so vector R also possesses x component in the x direction, written as x component of vector R. Similarly, we will draw y component of vector R. Right from the tail of vector AY to the head of vector BY. What is this? This is y component of vector R. Just as vector A and vector B are making angles theta 1 and theta 2 respectively with x-axis, so vector R is also making an angle theta with respect to x-axis. Now, from figure, we observe that x component of vector R is equal to x component of vector AX and x component of vector B. Similarly, y component of vector R is equal to y component of vector A and y component of vector B. Now every vector has a magnitude and direction. It means vector Rx has a magnitude Rx and a direction I hat, which indicates that Rx is in the x direction. Similarly, vector Ry is equal to magnitude Ry and direction j hat. Now we know that I hat, j hat, k hat are unit vectors which indicate the directions of x, y and z axes. Now let us find the magnitude of this resultant vector R. Now we have studied in class 9th how to find the magnitude. So give the heading magnitude of vector R, and we have also discussed it already in our previous lectures. Magnitude of vector R. This is R is equal to under root by Pythagoras theorem Rx square plus Ry square. Now let us find the angle which vector R is making with the x-axis. That is, let us find the direction of vector R. So we will give the heading direction of vector R, direction of vector R. Give the heading. For this direction, we will use the trigonometric ratio tan theta. So tan theta is equal to Ry over Rx. Girls, please note that I have not put any vector sign and I have not written any I hat, j hat, k hat while determining the magnitude and direction because they are simple numbers. So theta is equal to Ry over Rx. Keep in mind, for magnitude and direction, we will not write I hat, j hat, k hat or any vector sign. Okay, girls. Thank you.